All right, so we're going to continue graphing today. All right, but this time we're not going to graph rational functions like we did yesterday, like these. All right, so if you weren't here yesterday or you're still confused, come see me after school. We are going to graph what we call radical functions. All right, so every function that we're going to deal with today is going to have a radical symbol. So look at the ones in red here. We're going to be doing the ones in red. My two examples are going to be with square roots. And then on your own at your seat later on today, you're going to see what's going to happen with a cube root. Okay? And you will be responsible for both of those on the quiz on Monday. Yes?
Are we always going to be dealing with plus or minus?
So good question. We're actually not going to do a plus or minus. I'm going to talk about why that's there and why we're not going to do that. Okay? All right, so hopefully you got to take a look at this when you're sitting down. All right, we're going to talk about, again, I'm going to start with the square root functions. So my radicals are going to be a square root. So let's start with an example. All right, the way you want to do this, is first make a t-chart for your x and y. Now, I am dealing with a square root. So if I'm doing this and I don't want to have decimals, then I need to make sure that when I take the square root, what am I taking the square root of? Not a whole number. A number that is a perfect square. What are some perfect squares? 9. 2 is actually not a perfect square. 4 is. 6 is not. 16 is. Okay, we're getting a little high, right? I can't get that high off the grid here. So go lower than these. Go lower than these. 6 is not a perfect square. 2 is not a perfect square. 1 is a perfect square, right? Because 1 squared is 1. And my favorite one, 0. 0 squared is 0. So we're going to try to get those numbers inside the radical. But guys, as you look here, it says x minus 3. So if I plug in 9, what is 9 minus 3? 6. And then when I take the square root of 6, that is a decimal. Okay, so I don't want to plug those in. I want to do what? Plug in numbers that are going to get me that under the radical. So if I start with 9, what number minus 3 gives me 9? So I'm going to put 12 here. Because 12 minus 3 is 9. And what's the square root of 9? 3. So we can plot that point. 12, 3. So there's 12, 3. I got 12 because 12 minus 3 is a perfect square. So I'm trying to get those numbers in the radical once I subtract 3. All right? Everybody good with that? So how am I going to get 4? What am I going to plug in to get 4 under there? 7. Very good. Because what is 7 minus 3?
4.
That's 4. And what's the square root of 4? 2. So I'm going to plot 7, 2.
You did what? Why only 7 to why not 12 and 3?
I already plotted 12 and 3. You should plot both. Okay, I'm just going to go down your list. My next one says 16. So what am I going to plug in to get 16? 19. But guys, can I get to 19 on my x-axis? No. If this is 12, then my highest number I could use is 14. So I can't use 19. So we're going to skip 16 for this one. What about 1? 4. What am I going to plug in to get 1? 4. So what is 4 minus 3? 1. The square root of that is 1. So I'm going to plot 4, 1. And finally, my last one over there says 0. What am I going to plug in to get 0? Just 3. Because what is 3 minus 3?
0.
And the square root of that is 0. I'm going to plot 3, 0. And now you're ready to make your curve. Now you're ready to make your curve. All right, so I'm going to start at 3, 0. I'm going to make my curve. So watch how I make it. So, Roberto, you asked about that plus or minus. So we do not have a plus or minus. So guys, notice, do I have the other piece that's down here also curved? No. I don't have that, because that would be having that plus or minus. So we're only going to do it where they look like this. All right, so you're always, bless you, take it back. Your square root should always be like that. All right?
So if it was x plus 3, it would do the opposite?
No, if it was x plus 3, it would be actually, it'd start here and go like that. It'd still look like that, it would just be start at a different spot.
Well, then with the X and Y, you would add them instead of subtract.
You're right, so to get 9, I would have used 6. So it would have been 6 plus 3 gives me 9 in the square root. Alright, we're going to do another example. But before we move on, it says to do what? Domain and range. So let's talk about the domain and range. So domain from yesterday was what are my possible x values? Is it all real numbers? Did I plug in -2? What happens if I plug in -2? You get -5 under there. Can you do the square root of -5? No. So is it all real numbers today? No. So I'm going to use interval notation. It's been a long time since we've done this, since like September. All right, I know. We're what? September. It's been a long time. So what's my lowest x value? 3. So I'm going to write 3. Does that dot include 3? Does that point touch 3? Is it filled in? Yes. So watch what I'm going to put. I'm going to put a bracket. Hopefully this will come back to you. Put a comma. What's going to be my highest y value? Well, my highest x value. My highest x value. People say 12. But guys, look at what's happening here. It's going on which way? Forever. Towards what? Infinity. So it's not 12. My highest x value could be what? Anything you want. So that's why we write infinity. Now with infinity, what should it get? It always gets a parenthesis. Always. I know, it's a long time ago. All right, you're going to use this a ton in next year pre-calculus. A ton. All right, I know, exciting, excellent. I know, all the kids are very excited. Excellent. Here we go. The range. What is my lowest y value?
0.
My lowest y value is 0. Does it include that? Like, is it filled in? Yes. So you have your bracket. Now, I know it's hard to see here. It's slowly increasing, but it's still increasing towards what? Infinity. So my highest y value is going to be infinity with a parenthesis. Are there any questions about example 1? All right, Seth.
Will there ever be a time when the arrow is going
In this case, no. If it's a square root, it will go on forever in one direction. All right, my favorite band. So make sure you don't go on forever on this one. Do you see how I'm not going this way forever? Okay, if it's a square root, only one direction. All right, any other, disregard that. Okay, any other comments or questions? All right, so yes. Yes. You're going to do one of those at your seed later. Okay, good question. All right, let's try example 2.
Together?
Yes, together. Example 2. All right, I'm going to make my t-chart. And what were my perfect squares you guys mentioned like from the previous one? 9, 4, 16, 1, and 0. All right, in whatever order. I don't care what order. All right, don't be a slave to those orders. Okay? What? Why are we using them? Why do I always want to use those numbers? Because those are the perfect squares. And when I take the radical stuff, if I don't want decimals, they need to be perfect squares.
Why are they in that order?
Because that's the order you said. You could write 0, 1, 4, 9, 16. Doesn't matter. Yes. Now, again, doesn't worry about the order. Answer for me. Yes. All right. All right. So we're going to use 9 first. Okay. So we're going to use 9 first. So plug in 9. Plug in 9 right now. Plug in 9. Plug in 9. Look up there, not at me. Plug in 9.
5.
How'd you get 5?
3 plus 2 equals 5. And this is square root of 9, and that equals 3, and this equals 5.
Sounds good. Do we all agree with that?
No.
The square root of 9 is 3, and 3 plus 2 is 5. Yes? All right, so we plug in 9, we get 5, right? Square root of 9 is 3, 3 plus 2 is 5. Okay, so we'll plot 9, 5.
And then 4. 4 and 2, right?
Okay, so now we're plotting which one? 4. What's the square root of 4? 2, but I need to add 2. So you get 4. So I'm plotting 4, 4. Okay, one moment. Okay, the next one says 16. But again, if I plug in 16, can I actually plot that point? No, because 16 is off the grid to the right. Well, because you guys said it was a perfect square, and maybe in the future it'll work. All right, so then number 1. I'm going to plug in 1. Square root of 1 is 1. 1 plus 2 is 3. So 1, 3. And finally, 0. Square root of 0 is 0, but plus 2, so it's 2. All right, and you're going to notice that this curve should look exactly like the last one. Just notice it's in a different spot. You guys see how it looks exactly the same? It's just been shifted around. Okay? Okay. Now, most students with enough practice will get pretty good at that. All right? Because you're just picking the numbers you want to plug in, doing it, and then plotting those points. So I'm confident that you guys will get very good at that. But still, students struggle with domain and range. All right? I get it. It is something that it's hard to teach and it's hard to understand. All right? So always use your graph and your t-chart. So domain says, okay, what's the lowest x value that you were able to use?
0.
The lowest x value was 0. So start with that. Look at your graph. At 0, 2, is your circle filled in?
Yeah.
Yes. So I'm going to use what symbol with 0? No, what symbol am I going to use with it? A bracket, because it's filled in. It touches 0. Okay? Now, what is my highest x value? Well, you look over here and I did what? 9. But is that my highest x value? No, because this guy is going on forever, so it's going to be infinity. That's fine, just make it sideways, right? Just click on it and rotate it.
I have a question.
Yes?
Will that line always be solid?
Yes, this line will always be solid. Good question. All right, now the range. So it's asking, what is your lowest y value? 2. So you can use your t-chart or the graph. Right, the lowest y value is 2. So I'm going to write 2. Does it touch 2? Is it not a closed-in circle at 0, 2? Is that not closed in? Yeah, it's closed in just like before. Like filled in, yeah, like shaded in. Right, not open. This would be an open circle.
What are we getting those?
If it was like, no, but if it was like this, it would be a parenthesis.
Okay.
But it's filled in, right?
Well, then why are we putting a parentheses for infinity?
Because infinity is actually not something you can quantify, so infinity always gets a parenthesis. That's one of those unique situations.
So big to infinity.
So it would be 2 to infinity. Very good. I'm going to tell you right now, there's always going to be infinity in these, but you're going to see with the at your boards that it's going to be a little unique when you get a little trickier on
Why
some
do
of
you
your
always
problems.
do that?
Because it's fun. All right, so at this point, I want you to flip the paper over. And I want everyone to look at 1 and 2, just 1 and 2. What do you notice about 1 and 2? 1 and 2 are just like your examples. So when you're doing these, what should you do? Go back to your examples. Okay? So I'm telling you right now that you should feel confident that you can do 1 and 2. All right? But notice what I did at number 3. I changed the index. It's no longer a square root. What is it? A cube root. So when you do these, what are you going to plug in for your x? I need perfect cubes. 0 is a perfect cube. 9 is a perfect square, not a perfect cube. 27, but that's going to be well off my grid. 3 is not a perfect cube. I always ask kids, okay, 0 cubed is 0. What's 1 cubed? Okay, so that's 1. What's 2 cubed? 2 cubed. 2 times 2 times 2. 8. So that's my other one. Now, this is going to be a little different than the square roots. What number is here? What kind of number is that? It's an odd number, which means I am allowed to have what in the radical? Negative. So I'm going to write -1 and also -8. So you're going to plug those in. If you don't know how to do that, what do you use?
The yellow paint.
The yellow things, the calculators. All right, and then what's unique about number 4?
Negative.
There's a negative out there after you do the square root. All right, so what are you going to plug into this x value? 0, 9, 1, 4. What do we plug? What are those numbers? Are perfect squares, right? So plug in your perfect squares, but then you're going to make sure you do the opposites. Let's do one together. Which one do you want to do? 1. All right, what's the square root of 1? What's the opposite of that? So that's your y value. So in that case, it'll always be negative in your y. It's going to make it look funky, all right? But I want to do that for a reason, okay? You're going to stay seated. You're going to try these. I'm going to give you guys the rest of the class, which is a half hour. All right, I'll be walking around up and down, seeing if you have questions with the clipboard with the answers. All right, everybody begin.